Okay, another problem from section 10.3, and this is number 55. We want to find the area that's inside the circle, r equals 2, but outside the cardioid, r equals 2 times 1 minus the sine of theta. So I graph both of these. This is my circle, r equals 2, so it's just a circle with a radius 2. And this is the cardioid, r equals 2 times 1 minus the sine of theta. So you have to make sure you know these forms and how to graph these. We want to find the area that is inside the circle, so that would be inside this part here. That's a semicircle. I kind of drew it over here. Inside this semicircle, but outside the cardioid. So what I'll do is I'll take the area of the semicircle, and I'll just subtract this part here, this green part. Now this is the cardioid. Now if I take this and I start this at 0, and I find the area from 0 all the way around to pi, I'm going to get this area here. So I just have to take it from 0. If I take my arc and curve around here to pi, I'm going to get this part. If I keep going around, I'll get the rest of it. So it's going to start here, 0, and go right around. And you can try that. You can put that in your calculator and trace it. It should work out. Okay. So the area is of the semicircle, this whole part here, which is the red and the green. That's going to be 1/2 pi r squared. R is 2, so it's just 2 squared. So that's pretty easy. 2 squared is 4. Half of 4 is 2, so that's just 2 pi. Now this part here, this is the green part that I have to subtract. That's going to be the area of my cardioid from 0 to pi. Okay? And that's going to be 1/2 r squared. There's your formula. 1/2 r squared. Now I actually found, I just checked over here. I should say that I didn't check to see where they intersected, so I just set r equals 2 equal to the 2 times 1 minus the sine of theta. So what I did was I did find that they intersected. If I set this 2 times this 1 minus sine of theta equals 2, then I multiply. If I divided both sides by 2, I got 1 minus sine of theta equals 1. So if I added sine to both sides and subtracted 1, I got sine of theta equals 0. So that's 0 at 0 and pi. So that's where they intersect, 0 and pi. So I just double checked that. Pardon me for not going over that. So let's find this area. So now if we square this, we've got a 1/2 out here because that's part of the formula. If I square the 2, I get 4, and 4 times 1/2 is 2, so I can bring that out in front. I've got 1 minus the sine of theta squared, and I can square this out. So it's 1 minus 2 sine theta plus sine squared of theta. We can rewrite this. Now again we have 1 minus 2 sine theta, and then I could break this up into 1/2. And then again, I did this before, and I shouldn't have skipped that step because sometimes you guys might get a little bit confused on that, because what I'm doing is I'm setting up for the chain rule. Let me fix that now. So I have this 1/2 over here. And I need a 2 out here, so I'm going to put a 2 over here, and I'll do that in red, so you see how we do that. And this is a 1/2. Because 1/2 times 2 is 1, so I'm just doctoring this up, so I can use the cosine of u du, because the cosine of 2 theta is 2. So the 1/2 times 1/2 is 1/4, and there's my 2 over here that I put in to kind of make that adjustment, rather than have to do a full-fledged u substitution. Sorry, there we go. So 1/2 times 1/2 is 1/4. And now we're all ready to take our antiderivative. Again, we've got a 2 pi over here. That was our semicircle minus 2 times this whole thing. So the antiderivative of 3/2 is 3/2 theta. Minus, well, the antiderivative of the sine is negative cosine, so that's going to be negative 2 cosine. Remember, the derivative of the cosine is negative sine. So that's going to change the sign to positive 2 cosine of theta. And then the same thing, this is the antiderivative of the cosine, now it's just the sine. So this is just going to be 1/4 the sine of 2 theta. So we take our antiderivatives, and we evaluate those at pi and 0. So if I put pi in here, I got 3/2 pi minus 2, and times the cosine of pi. And the cosine of pi is negative 1, so that's going to be negative 2. And the sine of pi is 0. And then if I put 0 in here, I get 0. But the cosine of 0 is 1, so I get 2 times 1 is 2. And the sine of 0 is 0, so this is what we have. all times negative 2. So what I can do is this is going to be 3 halves, and this is going to be negative 2, and a negative 2 makes negative 4. And if I multiply that by 2, I get 2 pi. This is going to be minus 3 pi, and a negative times a negative is positive 8. And we end up with 8 and negative pi. Oops, sorry. Oh man, I missed all that stuff, sorry. So busy kind of pointing this out, and you can't see what's going on. Excuse me. So again, what I did was this was my antiderivative. I evaluated, I'll just show you again. I put this pi in here, so I got 3 pi. And the cosine of pi is negative 1. So 2 times negative 1 is negative 2. Sine of pi is 0. And I've got negative, and then that's the 0 there. But the cosine of 0 is 1, so I got 2 times 1 is 2. And the sine of 0 is 0, so there we go. All right, and then we've got 3 halves pi, a negative 2, and a negative 2 is a negative 4. If I multiply by 2, so I got 2 pi, negative 3 pi, and positive 8. And then I've got positive 8 and negative 3 pi plus 2 pi is negative pi, so there you go. Okay, so if that makes sense. Now the key thing is your sketch, okay? Take a look at your sketch. Make sure you take time to get that right so you can see the strategy you're going to use to find the given area. That's the red area. The part that's inside the semicircle but outside the cardioid. Hope that helps.